I'm not sure if I can hear.
Is it on my end or yours?
Oh, I can hear you now.
Oh, cool.
Yes. All right. Yeah. Hi, Tadeas. How's it going?
I'm doing great. How are you?
I am a-okay. Actually, it's a really nice day out here, so it's like a nice 78 degrees Fahrenheit.
Yeah,
Um,
it's
yeah.
actually nice here too. Shame I was rushing
Yeah.
to get the slides done.
Yeah. You got to sneak in a little walk after the talk or something. Oh, that's so crazy. Okay, wait, side fact. So we have some folks watching from all over the place. I always like to ask where people are watching from. Um, yeah, I see that we have some watchers from DC, from Merida, Yucatan. That's cool because my family is from Merida. So super fun. Yeah.
So did you get your family to watch this or what?
Oh, and Berlin. Oh my gosh. No, I don't think I know this viewer. We got Berlin, we got New York. Uh Tadeas, I think that makes you Mr. Worldwide. If only. Maybe if we like lose the hair and put on some I'm joking. Yeah, so welcome everyone. Welcome to the Chicago Kotlin user group. We're here with Tadeas Kriz today. He works at Touchlab. Tadeas, where are you streaming from today?
From Toronto, um, near the lake with a beautiful view of lake, which you can't see because I'm not in that same room.
Which lake?
I think it's the Ontario.
I should know these things, but I don't. There's five of them. Chicago's with Lake Michigan, so that's ours. So yeah, wonderful stuff. So would you mind telling the audience a little bit about yourself and what you do at Touchlab?
Sure. I actually had a slide for that. Um, but basically, I started with PHP development very many years ago, and one of the things I put on my slide is that I'm self-taught, which for me means my terminology sucks, and I apologize for it. So don't go too hard on me.
What?
Um,
Don't worry.
and I founded a development services company in 2014. We've done iOS first, and then we added Android. Then we moved to Kotlin Multiplatform, and then in this year, early this year, I joined Touchlab, where what I'm doing is basically like Kotlin Multiplatform R&D, trying to push Kotlin and the compiler to its limit so that we can improve usability, we can improve um, people coming to KMP so that they can easily get into it and like have higher adoption essentially.
Love it. And we'll be talking about metaprogramming, KSPs, Kotlin compiler plugins. If there's anything that you'd like the audience to really watch for in your talk, what should we be excited about?
Uh, so something I don't mention really in the talk is that um, Compose iOS is fairly usable now, and we've actually done some work in DroidCon app in Compose iOS, and it's been an interesting experience. I'm gonna say it this way, but it's great to be able to have this. It's not something that you would use in like definitely not in production app today, but I can see the future in it down the line, couple of years down the line. I think it's gonna be great.
Wow. So that's kind of exciting. Yeah. Well, thank you so much. I really appreciate it. I know folks are really excited to see your talk. Thaddeus, if you don't mind, I'm going to boot you off for just a minute or two. We'll run through some logistical items
Sure.
and then I'll put you back on and I'll let you take the floor. Yeah.
Thanks.
Okay. All right. Okay, yes. For folks that are just tuning in, welcome to the Chicago Kotlin user group. Today we're guesting Tadeas Kriz at Touchlab for his talk on metaprogramming with KSP and Kotlin compiler plugins. Okay, so a little bit about us. We believe in being inclusive. Chicago Kotlin user group is an inclusive group, so do everything to be curious, ask questions, and avoid assumptions. And we always encourage our members to continue to grow trust, empathy, and friendship. Okay, would you like to give a talk? We do have an open CFP year round. There should be a link at the bottom of the description. We've had both like new time speakers or first time speakers as well as very experienced speakers. Honestly, it's like pretty hard to tell the difference. The talks have been all amazing. If it's your first time, please don't be afraid. Definitely give a talk. It's a safe space to do that. It's a great way to expand your network. And of course, it always looks good on a resume. Okay, so we do have a channel on the Kotlin Slack. It's the hashtag Chicago channel. It's not crazy active. I'm hoping that maybe we could start using it more. So we'll be getting better about that now that we're kind of like finding our groove and things. And of course, we do have an account on Twitter at Chicago Kotlin, and you can also tag Tadeas Kriz at Tadeas Kriz. Okay, so in terms of live reactions and interactions, we do have a YouTube chat. Please feel free to use it. We'll be trying to answer questions and giving voice to that sort of thing. So yeah, feel free to make use of that. And then of course, you can always take screenshots and share it on Twitter. That's always fun too. That's everything that I have on my end. With that being said, I'm going to go ahead and bring Tadeas on screen, and we'll switch out. And maybe if there's a way I could, maybe it's an alphabetical thing. I'll just like remove myself and add myself. Nope, it's just alphabetical. It's weird. Okay, well, take it away. Sorry.
No worries. So let's begin. I mean, before we begin, I want to note that my internet connection has been kind of laggy in the past few days during evening hours. So if I cut off or anything, it's not on purpose. I'm not trying to get out of this. So let's begin with who, me. We already covered this, right? So let's look at the contents. I basically want to very quickly run through what metaprogramming road has been on JVM, and then we can look at the KSP and compiler plugins and how to use them and how to write the plugins respectively. Note that in the abstract, my estimate was kind of off, and we will only be scratching the surface of KSP and compiler plugins. But hopefully it will give you enough to take off from this and then just run with it and look at other. I've included examples at the end, so you should be able to look at them and hopefully understand where they are going. So what is metaprogramming? Now, it's not how it's not how Facebook does development in KSP and Kotlin. Metaprogramming is when programs read other programs and operate on them and do something on either source code or binary code or bytecode in between. One of the possibilities to do metaprogramming is reflection, again in JVM or in other languages. It's runtime metaprogramming, and it's very, very powerful. Unfortunately, when it comes to Kotlin Multiplatform, because we have JavaScript and native platforms, it's pretty limited on those platforms, and that's because reflection overall is kind of limited in native languages because they compile in a different way than Java or Kotlin in the JVM. Also, unfortunately, there's the lower performance, there's always performance hit. The good thing is that oftentimes you can use reflection where the performance of the reflection compared to something else you're doing doesn't really matter. So for example, deserializing or serializing JSON using reflection is usually fine because the most time your program waits is on the request to the server. So let's focus only on compile time introspection, which is the other way to do metaprogramming on JVM. This is basically a necessity for Kotlin Multiplatform metaprogramming. There's no way around that, unfortunately. You have to do either KSP or Kotlin compiler plugins. It has downsides. Longer compile times, larger binaries, and because it's done in compile time, the result is static. There's no way you could react on, let's say, user input or what the server sends you. Whatever you build into the app, it stays there. So this is the part where we look at the JVM history of compile time, introspection, and metaprogramming. It all began with APT, which came out in Java 5. The JSR 175 included annotations and also the annotation processing tool, the APT. Initially, it was separate from the Java compiler. It was a separate tool. It did invoke Java compiler, but this was basically like the first attempt on doing metaprogramming in Java, which allowed generating Java code or validating sources, among other things. But like it was kind of limited into these two categories. The great thing was that it would be multi-pass, so you could use what you already generated in previous passes. So that way you could generate code that you wouldn't use in other pass. Then with Java 6, we got APT replacement. This time around, they standardized the API, they built everything into the Java compiler, and as you can see, the packages are different, everything got standardized. Underneath, it was still using the mirror API from the APT, but you could have multiple implementations, like OpenJDK had it different and so on. Then we have Kotlin. And Kotlin, when it began, it didn't have any annotation processing. But then in milestone 12, they've added capped. At first, it was to allow Java annotation processors to run on Kotlin code annotated with annotations as well, which was great to allow like all of that has been written in Java to work for Kotlin. Unfortunately, in the beginning, you couldn't use the generated Java classes from Kotlin. So you always had to write some Java. You couldn't be all Kotlin. Then they added this second mode, which generates basically stubs where those stubs then can be compiled in the APT. That's, well, Java compiler, it's running the processor, and then it builds Kotlin afterwards and can use all of the generated classes. It's slower, but that's the it does more work, so it has to be slower. So with the history out of the way, let's head back to the future and let's see what KSP and Kotlin compilers can allow us to do. So KSP came out as a replacement for CAP. Among other reasons, it's faster and it can be multi-platform, where CAP was always dependent on the Java processing tools and needed JVM as a target. KSP allowed to add native and JavaScript targets. It wasn't initially that, but they've added the support. It is made by Google. It is, I think, supported by JetBrains. I'm not sure if that's the right word for that, but basically, KSP documentation is part of the Kotlin documentation now, and capt is in maintenance mode from now on. So there's not gonna be any new features. There's probably not gonna be stabilization of experimental features of capt. So if you can, if you're using capt and you can switch to it, switch to KSP. The support for KSP is growing. There's libraries that were previously just capt. They are supporting KSP now. So that's going great. What KSP brings, what's great about it is that the processor API is stable. So any processor, any annotation processor you write, you won't be needing to recompile or change it or maintain it over different Kotlin versions. The API is very similar to Java annotation processing API. It's not 100%, and it's not their goal either to do that. However, it also supports Java sources. So essentially, you should be able to migrate your capped processors to KSP processors and still use them even if your project uses Java sources. And last but not least, it's just well documented. It's especially when compared to Kotlin compiler plugins. I'm getting a little ahead of myself here, but it's well documented. It's easy to find what you need to do with it and how to do it. It has limitations, and those limitations I'm mentioning here are mostly are set by the Google team working on KSP, that these are not goals of KSP and never will be fixed. Unless they change their minds, that's something else, right? So no expression level information of source code. What it means is you can look for methods, functions, classes, interfaces by annotations. But if you look at a method or a function, you cannot introspect what's inside its body. You only get the signature of the method or function or properties, you know. So this is this limitation you need to keep in mind, that that's just not possible. You also can't, and that's the way it all works, you can do source code modifications. Not just source code modifications, but you can change the IR, the intermediate representation of Kotlin either. You can only generate new Kotlin files. And yeah, so there's no IDE integration. That's just limitation that's gonna change. This isn't something that they need to support, because if you add the directory as a generated Kotlin sources in your Gradle, it just works. But hopefully they will add integration so that you don't need to do that. As I mentioned, we are only going to scratch the surface on how to use KSP. Thankfully, there's a great quick start guide. It's something that wasn't like in the beginning wasn't that great, so it was difficult to get into it. But now, all you need to do is go there, read it, follow it, and you'll be good. However, let's look very quickly at how to do this. So this is what you would do in the module you're implementing your processor in. Notice that we are still using Kotlin version and KSP version. Every release of KSP, the API doesn't matter that much, but the implementation of the KSP is always bound to a specific Kotlin version. So this is something that you need to keep in mind. Whereas capt didn't have that limitation. KAPT is working everywhere because it's built into Kotlin. So we add it's a regular JVM. JVM module, we add the API as a dependency. And then there's two interfaces that you need to implement. The first one is the symbol processor. The symbol processor has an entry point called process. You get the resolver. On the resolver, you ask for annotated declarations. It will give you that. The result, the list of KS annotated, is whatever types you couldn't resolve. So essentially, KSP is doing multiple passes as well as capped, but this way you can tell which types you still couldn't recognize and resolve and process, and tell KSP to do a second run. So this way, it's more cooperative. Whereas, if I remember correctly, in capped, it just looked at generated files. If something is generated, it will do another pass. If not, it's done. Then there's the optional finish and on error. That's mostly like when the processing is done, you can do any cleanup, or if it fails, you can do any cleanup. So that's the processor. And I'm missing, yeah. And then the second thing is symbol processor provider. In the capped and APT, you didn't need this. You just need the symbol processors or annotation processor in their case. Here we need to implement the provider, which basically just creates an instance of the symbol processor you've implemented. The last thing you need to do, which I don't have a slide for, is either use Autofactory from Google and annotate your implementation with Autofactory and then give it this symbol processor provider class, or you need to register it as a service into your meta inf dash services in your resources folder. It's usually easier to do it with the auto service. So that has been the KSP, as I mentioned, just like looking at it in very lightly, because we can now get into compiler plugins, which it's just a different beast. It's way more powerful. It allows you to do transformation of the IR. You can do synthetic declaration. You can add errors into expression, so you can add separate validation. You can add a lot into Kotlin. What you can do at this time, you can really add new things to Kotlin syntax, which is something that may come with the new frontend, with the K2 frontend, but we're not gonna look into that. However, with this all great and powerful stuff comes something that should scare you, I would say. There's almost no documentation for none of this. So whatever you can find, you would be digging through the Kotlin compiler code. You will be digging through other plugins, all of that. There's just basically nothing. And the setup, it's really complex. And also, the API is unstable. As I mentioned, KSP is releasing their implementations and they are bound to a Kotlin version. That is because the Kotlin compiler API is unstable, and because KSP is compiler plugin and uses this compiler API, they need to release new versions because it breaks between Kotlin releases, usually. So what plugins are there? What can you look at? We have the KSP, but it's gonna be a difficult one because it provides you with ability to add plugins in, so it's itself very complex. Then you have the Jetpack Compose, which again, very complex thing. And then some of the easier to grasp Kotlin X serialization. So this is what generates the serializers that can then be used by Kotlin serialization in runtime. You have the all open, which is used on backends, and it basically in Spring and Enterprise Java, you usually need all your classes to be open so that they can be inherited by proxies. And Kotlin classes are all final by default. So this plugin goes through all of that and changes all final classes to open. The no arc, again, similar to the all open, it's usually used on backends. It makes sure that there's always a no argument initial constructor in your classes. These three plugins, they're not the easiest to read, but that's by the thing that they are compiler plugins. But they will provide you with the best documentation you can find. So let's quickly look at the plugin structure. When I say that it's very complex, I mean it. You need at least 2 modules. Previously it was 3. You need 2 modules, one for the Gradle plugin and one for Kotlin plugin. Oh, the Kotlin compiler plugin. There's a possibility to not, I made a mistake here. I wanted to split the Gradle from Kotlin so that you can see like what comes from where. The plugin interface is from Gradle and the rest is from Kotlin compiler. And now I'm seeing that what I would like to say more is that the plugin and subplugin are in one module, in the Gradle module, and the rest is in the Kotlin module. So you have the plugin applies the compiler subplugin, great name. Then we have an optional command line processor that's used to parse options that the subplugin provides into the plugin, into the Kotlin plugin. Component registrar, which takes care of registering your components, extensions. And we have the separate extensions, which we'll look into in a sec. Let's look at the plugin real quick. It's if you ever worked with, if you ever did Gradle plugins, none of this will surprise you. It's just an API to declare Gradle plugins. You have the entry point apply, and in it, what we do here, like just the most simple thing, is applying the sub plugin. That's the Kotlin compiler sub plugin. We usually would do more. We would register an extension so you can configure the plugin. We may need to register tasks so that the Gradle would do more. But for this example, we are just applying the other plugin. Oof. Okay. For the Gradle plugin module, I didn't include everything you would want there, but this should be the important thing that you need in there. The JVM plugin and Java Gradle plugin, those allow you to declare, I mean the Java module, of course, but the Java Gradle plugin allows you to declare the Gradle plugin. Then we create it, we set its ID. This ID is the ID you use when you apply a plugin in a different Gradle module. And then an implementation class. This is the class we've seen in the other slide. It has to be the fully qualified name. So make sure that when you're refactoring, you remember to change this. Oh, and I just wanted to mention these dependencies. They just add you the APIs to declare the Gradle plugin and also the Kotlin subplugin. So this is the interface for the subplugin. I just want you to look and experience the name of it, which contains 2 plugins in it. Um, Again, it's it itself is a Gradle plugin, so we could potentially just implement this and do everything here, but for some reason it's not recommended that every uh, uh, every um, every Kotlin plugin is doing it separately. And we have the um, here we have the is applicable to just decide like whether it should apply or not. Then it applies on your compilation. That can be either JVM, native, or JavaScript. So you can do things differently based on what platform you target. Um, oops, that's a wrong name. So in here, get compiler plugin ID, you would have an ID which I have somewhere else too. This is to tell this subplugin which Kotlin plugin it's adding options to. So it's adding the arguments to. These two have to be then in sync, otherwise it doesn't work. Then we have the get plugin artifact. That's the last thing you really need. Since Kotlin 1.7, you don't need anything else, and you just need to get that subplugin artifact out. Skip the rest. Again, very simple example of the Kotlin subplugin you may want to write. It's applicable to any compilation. So this will try and run the apply to compilation on any compilation. We don't have any options, so we don't provide any arguments to the Kotlin plugin. Notice the get compiler plugin ID. This is where we have that compiler plugin ID. This is different from Gradle plugin ID, and you don't like use it in other Gradle modules directly. And then we have the subplugin artifact. It's a Maven artifact, and this is the group, project name, and then the version of the Kotlin module. You should probably use a plugin like build config to put real values in here that are from Gradle, not written directly, so that it's easier when you refactor and stuff. And I forgot that I have these again. And then now we're going to the compiler plugin module, which again, simple JVM module. We don't want to do anything crazy here. We need the compiler embeddable dependency. Sorry about that. And then I've also added an example of the auto service because we will be I'll be showing like how it's used in the compiler plugins. This is the interface of the processor. The plugin ID, that's the plugin ID we've discussed before. We have the options. So the plugin can declare, you declare options that the plugin can accept, also options that the plugin needs to accept. So whatever you do here you do that. And then you have the process option, which is called for any option you provide through the subplugin, through the Gradle subplugin, and you take it from the value, change it to whatever type you need to, basically like deserialize it and put it into the compiler configuration. Gosh darn it. I tried to do something that you can copy paste to your project if you're doing this. It doesn't have any options, but this is what you need to add them. You would then do when in the process option on the option name and decide how to configure the configuration. And this is the auto service I mentioned. So this is how you don't then need to create the service registration yourself. you just add that on the class, and it will use capped, which we covered before, and we will use capped to generate all of that for you. And almost last thing, I know this is a lot of stuff, which I'm basically like reading the interfaces of. So we have the component registrar. It's used to set up and register your extensions based on the configuration you provide. So, for example, here you would either enable, disable some parts, some parts of your plugin. So maybe you don't do everything, because there's a lot. These are all the extension points that are supported in Kotlin currently. We probably only, well, most of us, I would say, only need 2 of them. First one is the synthetic resolve extension. And the second one is IR generation extension. If you want to see in, as I mentioned, since there's basically no documentation, the way I recommend working with this is cloning the Kotlin compiler repository, opening it in your IntelliJ, and then just going through it. The function register plugin extension points in the Kotlin repository, that's where all of these extension points are registered, and you can go from there and look what those extension points are used for and their implementations, which is basically the best way you can learn more about the other extensions. But I'm gonna cover these 2 because they are pretty interesting. The synthetic resolve extension, it allows you to, 1, create new classes, or extend existing classes. So you can, there's a lot of functions inside the synthetic resolve extension interface. Some of them are to provide new properties into a class. Some of them are to provide not subclasses, but nested classes. Some are to provide methods. And you can use this synthetic resolve extension to provide the Kotlin compiler with a new symbols. So this, when you then write Kotlin code, Kotlin will see these new things in your classes, in your interfaces, wherever you add them. This extension is required anywhere where you need something to be visible from your code. When you're not doing just something that's in runtime, you need the synthetic resolve extension. One thing to note, you need to also build an IntelliJ plugin if you want to use this extension in your IntelliJ and have code completion. Otherwise, IntelliJ won't see those symbols. Your code will compile fine, everything will work, but you won't see them in code completion, and in IntelliJ they will be red. And the second extension is the IR generation extension. It's one of the most powerful things you can, at least to my limited knowledge of the Kotlin compiler, that you can use in Kotlin compiler plugins. It allows you to add and modify declarations. And not just declarations. You can go down to the expression level and change expressions to whatever you like. This is used by Jetpack Compose, and if you look at the IR code, when Jetpack Compose converts all of your composables, you can see that they have way more code that you've written. They have more parameters in the functions than you've written, and they work in completely different way than that you've written. All of that is achieved with, most of that is achieved with the IR generation extension. And I almost forgot, if you use the synthetic resolve extension, then you have to use, mostly have to use the IR generation extension to generate IR implementations for those synthetic declarations. Otherwise, On native, it just won't compile. It will crash the compilation. On JVM, sometimes it works because JVM is way more lenient when it comes to ungenerated bytecode from the IR, but on native, it's way more strict. So just keep that in mind. And now we're getting back to the component registrar. Once we looked at the synthetic resolve extension and IR generation extensions, this is the way you implement it. And then if you have, again, we register with the auto service, we implement its entry point method, and then this is how we register the synthetic resolve extension. In here, my synthetic resolve extension will be implementing that interface. You can give it any parameters you want. It's kind of straightforward. As I mentioned, all documentation is plugins, other people's plugins. So let's just see where we can learn more about them. Where is it? Some are in the Kotlin repository in the plugins directory. I included links to all of them, so you can quickly look at them. Then we have the Jetpack Compose, very complex plugin, but very interesting to read through it, especially if you need to do the IR transformation and change some extensions. Look into that, read it. It will give you a lot. KSP is great if you need plugins inside plugins, because you have all of that in there. And then kind of a shameless plug, Hyperdrive, which is an undocumented library that nobody ever used. But there's Kotlin plugins in there, and there's been some challenges that I had to solve, especially in the Multiplatform X plugin. I will get to them a little later, but it's interesting if you want to see again more about how the plugins work, how to implement your own. In the abstract, I promised one thing: how to choose whether to use KSP or write your own compiler plugin. It's actually pretty simple. You just follow this diagram. Do you need to modify the existing code? Yes, it has to be a compiler plugin. There's no way to do that with KSP. Do you need to access expressions? Do you need to get into functions and read what's in them? If yes, it has to be a compiler plugin. In any other case, you should try and use KSP as much as possible. So there's a stable API. You won't need to test your, well, you should, but you won't need to test your processors with every Kotlin release, even the minor ones, because KSP does that for you. They release new versions whenever Kotlin is released. Do we have any questions?
Tadeas, that was a great presentation. Yeah, definitely feel free to ask any questions you might have in the chat. I'll be sure to give voice to them. Yeah, I actually really enjoyed, being able, just having someone sit us down and just be like, you probably want to use this. Sometimes we just really need that guidance.
So we have a question about the
We have a couple, yeah.
Kotlin compiler frontend, whether it has the same setup. I'll be completely honest, I have no idea. I haven't used that yet. I hope to get into that at some point in the future. I am pretty sure that it will be very similar because they usually use the same extension API for most of the stuff. Yeah.
Yeah, I guess Rob might be talking about the FIR bit.
Yeah, that's what I
Yeah.
meant. That's the K2 frontend compiler. Yeah, once it's like more stable, then I think that it would be great to get into that right now. I don't think it's a good time, but maybe some experimenting for sure.
Yeah, the FIR. Um, yeah, I mean, I know there are some like there are some differences between using FIR and IR. Um, I think like
The FIR,
yeah,
if I remember correctly, it just gets translated into IR later on. It's like an intermediate, like the front end intermediate, and then it gets translated into IR.
yeah,
And
I don't
then it
think
gets
it's quite
compiled.
ready yet, but yeah. Oh gosh, we've lost some stuff. Sorry, I lost my place in the chat. Okay, have the same setup. It's but yeah, the long and short of it is it's very, very similar. If there are differences, it's pretty subtle. I would say like the experience kind of feels the same. You just want to make sure you're using the right the right IR with whatever you went with for that resolution part. There's another question. Is there a public repository access? Is there a public repository to access this basic Kotlin compiler plugin setup?
Thank you, Eduardo, for that question. I actually forgot to mention that there will be. I don't have it ready yet.
That's sick.
My procrastination, but I will definitely release that. There will be more than just in these slides because I didn't like. Oh, even now it was way too much stuff in the slides. Um, what you would want to do is have, if you look at, for example, the hyperdrive plugins, there's a lot more around like the plugin options. You have a lot more around the configuration, and if you have multiple Kotlin plugins, but you don't need to use all of them in your projects. There's a lot of ways to make that happen in a way that simplifies the configuration.
How soon do you think this will be up?
I don't want to promise anything. I do have a final exam in my university next
Okay,
week.
school comes first,
So
obviously,
after,
and then
hopefully,
after
I
that,
don't
maybe
do that
DroidCon.
between, yeah, between DroidCon and the school.
Yeah,
So when I get back from the school, then probably then.
love it. Okay, what would you recommend for testing?
Oh, another perfect question. So there's this library called Kotlin compile testing, I think, which is used to test the Kotlin compiler plugins, but it also has submodule for KSP. So if you want to test KSP annotation, well, symbol processors, you can use the same library. It's pretty great. It basically runs it runs your it runs the compiler in tests to compile your Kotlin with those processors, and then you can then you can check outputs, you can check the results, and so on.
This is really cool because I think I actually know the person who made this library, and he's
That's
very
awesome.
knowledgeable on Kotlin compiler stuff. I think he kind of like did a lot of help with like the Arameta stuff. So yeah, his work is amazing. Let's see. Oh, next question. What extension should I use if I want to add a new property to an existing class? I think I like this question a lot because I think it like gives a great example. Like we could go back to that one slide with all those extensions.
Yeah. Where was it here? One more.
Yeah, that's it.
So
So
it really depends. Do you need to access that property from your Kotlin code? If the answer is yes, you need to use synthetic resolve extension and IR generation extension. These two. The synthetic resolve extension to tell Kotlin that there is this property. You can say that it's private and it will just appear there and it won't be available from outside. The IR generation extension then needs to be used to implement what that property does, what it is, essentially. it allows you to set a value to it or add it. You can change the um, constructor to assign something to it, or it can be computed property. All of that is done in the IR generation extension. Just keep in mind that the synthetic resolve extension will create those properties for you. So you will not be creating new properties inside IR. You need to find that property and add the body to it, or the assignment. It's a little weird. I was struggling with it before at first because you would get like duplicate stuff in there, but it's already in there when you use synthetic resolve extension.
Okay, let's see. How hard is it to keep up with the Kotlin compiler plugin as new versions of Kotlin come out? Are there always breaking changes?
So this is this is quite difficult to answer because sometimes there are like every like the minor release. So if you have 1.6.0, then 1.6.10, so between those, sometimes there's been like I want to roll back. It also depends on what extensions you use. Some extensions, and also what APIs you use in those extensions. Right? Like you need to get types from somewhere. You need to resolve types inside those extensions, and some of those are more stable than others. So it really depends on what are you using, what you do. It's just better to double check and test it, and also if you have that like the manpower to maintain the plugin, then to also have a check on Kotlin version. So you always release a new version with new Kotlin and bind it the same way KSP does it. It's just safer.
Yeah, I think there's a lot of value in being able to understand what the trade-offs are with being able to have a little bit more power with what you do. We have another question. Is Touchlab actively hiring new Android devs interested in KMM? Eduardo, would you mind, when you say new Android devs, do you mean like novice or junior? Well, let's just assume that he did ask that.
Yeah,
Yeah.
I'm not sure about junior positions, to be honest. But I'm pretty sure that anyone who like the senior developers are always needed everywhere. I unfortunately don't know the levels we have open positions for. That would be more to our
Oh, not
to the
junior,
rest of.
sorry.
Yeah, definitely reach out.
Okay.
I should have prepared for this question, honestly.
Yeah. Oh, so I think he meant like Android devs, like now I want to go to like Kotlin Multiplatform. Yeah.
Oh, I see.
Okay. Sorry. Okay. New positions interested in Kotlin Multiplatform. Sorry about that. I feel like I butchered that. Sorry, that was my fault.
No worries. No worries. Yeah, definitely reach out. I'm very heads down on the Kotlin research, and I am very sorry that I haven't prepared for this question. I should have had that in. I will do better next time.
Oh, there's no sweat. You're welcome to always come back to both the meetup and the channel, and feel free to like add extra links or anything like that. And of course, if you're going to DroidCon New York, Tadeas will also be speaking there. So if anything, this is kind of like a sneak peek to one of the DroidCon talks. So very exciting.
Yeah. Amanda, do we have some more time?
Yeah, we have
I
we
have
have a little
a
more
couple
time.
more slides. Those are more of a interesting tidbits that I've learned doing this.
Oh, we'll share
And it
those.
can help in at least some cases. So definitely something to look out for. I call these hard lessons because it had been painful to get this right. This first one is the most important one, and I always forget to do this. And then I'm like, why doesn't IntelliJ stop on breakpoints? What's happening? And the reason for that is that when the Kotlin compiler is being ran by Gradle, it has its own daemon, if I'm not mistaken. And if you don't include this in your Gradle properties in the project you're building the Kotlin plugin in, it just won't stop there because it's running in a different process. So it's not bound to the same. It's not bound to the debugger and can't interact with it. Oh, we have a how do Kotlin compiler plugins affect compile times question. Is it as bad as capped? Um, First off, I personally don't have reference on how bad capped is, and definitely not compared to Kotlin plugins, compiler plugins. The great thing is that when you're implementing those plugins, you're taking advantage of all of the extension registry of Kotlin. So you're using the same APIs that Kotlin does. So it really depends on what you're doing there. Um, the more you do, the longer the compile time will be. But if the way I understand it, KSP, they are saying that even without optimizations, it's up to 2 times faster than capped, and it's doing basically the same thing that cap does. So take that as you will. It probably just means like the better you optimize your compiler plugin, the better it will be.
Okay. Oh, I guess you got some other hard learned
Yeah.
lessons. Yeah. I'm like, man, I can't believe you put these at the end. These seem kind of important.
Those are like if we have enough time, we can
Oh,
chat about.
I see. I see.
Uh,
Yeah.
second thing, when you have the synthetic resolve extension, as I mentioned, it has a lot of different methods that will be called by the Kotlin compiler, and you just answer by like it may ask you what extra properties are in this class, and you just respond with a list of strings. And if you need to ask the same class what properties it already has, that's where you can get into issues, because your code is probably being called because somebody asked that class what properties it has. So if you ask the same class or the descriptor of the class, it will crash in the plugin and it will not allow you to get that. There are ways around it. I honestly don't even remember. There's been so much time between when I've been doing this lazy resolution, but it's done in the hyperdrive in the Multiplatform X, where what I'm doing in the plugin is I'm synthesizing new property for every property in a class. So I need to ask the class for properties, and there's a workaround for this lazy resolution recursion crashes. Then we have something for the native. As I mentioned, when building the IR to native, it's not as lenient as JVM. JVM will let you go and let you build basically anything, and it will very probably even run and not crash in runtime. However, you will get issues with native. This is one of them. Whenever you see the error not found index IDX for something, it usually means that you're missing a generic parameter declaration somewhere in the generated IR. It's usually when you want to call some generic method or function from IR and you don't add the second parameter of the IR call instruction. Because in native, it needs to know what the generic types are. There's no erasure, if I understand correctly, in Kotlin native, so it needs to know. If you don't specify, expect the not found IDX for X. And again, this way you can find, okay, that's probably the issue. Then a fun one. I have two of them because they have different error messages or like what happens, but they are very similar. So this one, if you see an assertion failure, either during, I can't remember, I think it was during build, but it might be during runtime. If it's assertion failure in the debug utils kt.location property, it's because you forgot to set the start or and offsets in the IR declarations. Whenever you declare new stuff in the IR, you need to give it start and end offsets. It's usually best to, there's a way to specify them. Again, best to look at other plugins, how they do it. But if you don't specify them, or if you specify them wrong, this is the crash you'll be getting. Basically the same, the error message is different. Usually this is where you create a new function, little different from the previous. These are usually classes and properties. This one's usually for functions. And get in touch if you want to know more. Just like there's so much stuff I couldn't put into these slides. Even the stuff I did put in felt like it was too much. So just get in touch. We can chat about it. It's really interesting stuff.
It certainly is. Thank you so much, Tadeas. Really appreciate it. Yeah, I think we're questioned out here. No, these were really, really, really solid questions. This was a really great talk. Thank you so much for your time. Yeah, and thank you all for coming to this month's Chicago Kotlin user group. Yeah, please don't forget, our CFPs are always open. And Tadeas, I guess we'll see you at DroidCon next.
Yep.
Yeah.
The same talk, hopefully with some fixes from this one.
Yeah, that's the best part about these things. They're always recorded, so you can face the music. All right. Thank you so much. And thank you all for watching.
Thanks, Amanda.
Yeah, this was a solid session. All right. See y'all later.
Have a good one.